Guys, Miss Smith here with our Module 5, which is fractions, and its Topic C quiz, which we are dealing with fractions on a number line, rulers as fractions on a number line, and then graphing or plotting on a line plot fractions. So let's get right into it. Number 1 says, which fraction does the point on the number line represent? So what students need to understand is from 0 to 1 is an interval or one whole jump, one whole number. And anything that comes between there is a fractional piece. It's not a whole, so it's smaller than one whole. And we then need to figure out how much they have partitioned that whole into. So I look at each of those tick marks on my number line to determine that there are 1, 2, 3, 4 pieces in that whole. Then I can label. This is 0 of 4 pieces, 1 of 4 pieces, 2 of 4 pieces, 3 of 4 pieces, and 4 of 4 pieces. So this point is at the 2/4 mark. Number 2, partition the interval into equal parts and label 1/6. This is telling me the amount of parts I need on this interval or this number line. So I need 6 equal parts. I can start by partitioning that line into halves, and then I know that 3 and 3 make 6. So I need 3 parts on each side of that half. I'm going to put 2 lines here to make 3 parts. 1, 2, 3. And then 2 lines over here to make another 3. 4, 5, 6. Then it says label the 1/6. Here would be 0/6. This first tick mark would be 1/6. So I would put my dot there and label it. Number 3 gives us a line plot with fractional pieces. Gabe measures the lengths of several rectangles. He uses the measurements to make a line plot. So this is just his information. We're going to use that to answer the questions on the next page. Gabe measures one more rectangle. Which line plot shows the length of all Gabe's rectangles? So they're basically saying, here is another rectangle he measured, and it is now on the line plot, and it was not before. So I have to figure out what is the length of this rectangle that he measured, because that's what he's plotting. I go from 0 to 1, 2, 3, 4. Now this rectangle is more than 4. So I have 4 and a fractional piece. I'm going to look and see how I'm partitioned. I have a half here, and then 1/4. This would be considered 2/4 or 1/2, and 3/4. His rectangle is 4.5 inches. So I look at this first line plot. There is no X at 4.5. So this is not his line plot. There is no X at 4.5 on this one. So this is not his line plot. Again, no X on this one at 4.5 inches. So this is not his line plot. And then when I look at my last choice, there is his X on the 4.5. So D shows where he has labeled a line plot with all of his rectangles. 4. Measure and record the length of each paper clip to the nearest inch. So I'm going to start at 0. I go to 1 inch, 2 inches. This paper clip is 2 inches in length. The next paper clip is 1 inch, but not all the way to 2. So I look, this is my halfway point. So I'm at 1.5 inches. 1.5. This one goes to the 1, and it also goes to the 1/2 inch. Again, 1.5 inches. My next paper clip, 1 inch, 2 inch, and then to the halfway point there, 2.5 inches, 1.5. We're going to need this data for our next question. Part B says, use the measurements from Part A to complete the line plot. So I need to look back at my data. My first paper clip was 2 inches. So I'm going to look across until I find the number 2. I'm going to come above it and give myself an X to show there was one paper clip that was 2 inches. Then I had 1, 2, 3 paper clips that were all 1.5 inches. So I'm going to come on my line plot, I'm going to come across to 1.5, and then I'm going to do my best to line up my first X with that other guy, 1, then I'm going to do another one on top, 2, 3. There were 3 paper clips at 1.5 inches, and then my last measurement was 2.5 inches. So I come over to 2, 2 1/4, 2.5, and I'm going to try my best to keep that in the same row. So there are the X's or plots for the paper clips I measured. Number 5, use the number lines to decide whether each statement is true or false. Okay? 2/4, so I'm going to find where 2/4 is the same as 4/8. If those are directly on top of each other, they are equivalent or equal to each other. They are equal fractions. This is true. 3/8, so I'm going to find my 3/8, is equivalent to 3/4. These are not on top of each other, so this would be false. 0/4 is equivalent to 0/8. I can box those in because they are equivalent. They are right on the same place. They are equal to one another. And our final question, number 6, use the number line for Part A and Part B. Complete the number line. So they have used one number line to show 2 different partitions or 2 different fractional units. The top has been divided into thirds, and for the sake of clarity, I'm going to use a blue pen to show where my thirds are. When I begin, I have nothing, so I have 0/3. They have marked 1/3, 2/3, and when I have all the pieces, 3 of 3, 3/3, that is the same as having 1 whole. Okay, the bottom, they have partitioned into 1/6. So I can use my pink pen or purple pen to show all 6 of my pieces. I have 0/6, 1/6. This would be 2/6, 3/6, 4/6, 5/6, 6/6. And again, when you have all the pieces that you have partitioned, you have 1 whole. The second part says complete each equation to represent a pair of equivalent fractions. 0/3, I can box it in, is equivalent to 0/6. 2/6 is equivalent to 1/3. 2/3 is equivalent to 4/6. Hope that is helpful for you as you study for your Topic C quiz on fractions.